some of you asked me for help, but on Tuesday this week, I did 3 examples. I did 3 examples on how to do similar questions. So when you don't know the CDF, you only have the PDF, how to check the 3 conditions, 1, 2, and 3. So if you could go through the video, I don't know whether all of you were there on Tuesday or not, but if you could go through the video on Tuesday, which is in the YouTube channel, then you should be able to do quiz 1 without problems. Okay. All right, guys. So let me start with some questions. Okay, here we are. This is question one of the tutorial sheet is asking you to find the derivatives. So this is the density, the CDF of the Gumpel, right? So CDF of the Gumpel, which is given as, I'm sure it's given as this, right? X from minus to plus infinity. Okay. Taking the derivative with respect to x gives you with respect to x gives you this. All right, so this is the derivative of the of capital lambda, right? All right, the next one is the CDF of the pressure distribution, and which is given by this, yeah. And so, and you should take the derivative of this with respect to x, you will get this, okay. And finally, you are given the CDF of the Weibel type as being equal to this. Okay, and you should take the derivative of this with respect to x. You will get the following. Okay, so this is the answer to question 1 of the tutorial sheet. Okay, guys, any questions on this? Are you okay with this? I mean, just a simple matter of differentiation, right? Question 2. So, are you guys okay? Yeah. Okay. Question 2. Question 2 is to find the mean corresponding to each of the 3 types. So question 2 is to find the mean. So let's take the Gumbel type first. If you take the Gumbel type, the mean is gonna be because the limits of integration are from minus infinity to plus infinity of x times the density function, which is we worked out in the previous part. This is the density function. Okay. All right, so we need to find the integral of this, guys. Okay. Obviously, you can do it by different ways. One way is to substitute. Okay. Y equal to this. So x equal to okay. So under this substitution, this is what you get. Now you should sub this into the above. You will get minus infinity. Under this substitution will go to plus infinity. Plus infinity will go to 0. Okay, like this. All right, this is what you get. Okay, so you see that the y here and the y will cancel. Now I'm going to choose the minus sign here to change the limits around. So this will be, pull the minus outside, so it will be minus of the integral from 0 to infinity of log y e of minus y dy. Okay, now this is where one of the tricks, if you look at the I'm sure you guys looked at the preliminary video. One of the videos in the preliminary section says this. You probably remember this. This is a trick. This is a trick on this is a trick on differentiation. Okay, this is a trick on differentiation, guys. Okay, you hopefully you remember this. And I did a video on this under the preliminary section. Okay. Okay, guys. So now if you replace log of y by this, right? You will get you'll get this. Right now, I'm going to take the derivative operation outside the integral. So this is going to be minus d by dA in brackets Okay, you got this, all right. Now this integral here, it should be familiar to you, is the gamma function, which is again, I did a video on the gamma function, you may recall, in the preliminary section. So what you have is d by dA. This is the gamma function at a plus 1. All right, at a equal to 0. So the final answer that you will get is okay. So that's the answer to the first part of question 2. Now you need to do the same thing for, this is for the Gumbel type, this is for the Gumbel type. Now you need to do this for the Frechet type and also for the Weibull type. So let me show you how to do that. Was what I've done so far clear to you? Any questions? Please feel free to ask any questions you have. For the Frechet type, please use the chat box or use your microphone. Okay. The mean is gonna be the integral from 0 to infinity of x times the density function, which is okay. Now this you can write as, you can pull alpha outside. Okay. Now I'm gonna make a substitution. Okay. So x will become y like this. Okay. And dx by dy will become minus 1 over alpha. Like this. Okay. Now if you make this substitution into the integrand, this is what you will get. You will get alpha. The limits will change. When x is 0, y will be infinity. When x is infinity, y will be 0. So you have y okay, like this. Okay. Now now I'm gonna use the minus sign here to change the limits around, right? So, and the alpha here will cancel with the alpha here. All right, so it will be 0 to infinity of okay, like this, and this is okay. So this is the answer to the Frechet type of question 2. Okay. Any questions so far, guys? Hello, talk to me. Just if anything not clear, please talk to me. Okay. All right. Okay, so this is the answer to the Frechet type. So I've derived the mean of the Frechet distribution by taking the integral of x times the density function integral from 0 to infinity. Okay. All right. The next thing is the variable type. Okay. So for the variable type, so the mean is gonna be here. The limits of integration are from minus infinity to 0 of x times the density function, which we worked out earlier to be equal to this. Okay. All right. So this you can write as, you can pull the alpha outside. Okay. Then you have x times minus x power alpha minus 1. Okay. All right. This is what you get. Now I'm going to make a substitution. Y equal to this. So this implies that x is equal to minus of y to the power this. All right. And dx by dy is gonna be this. All right. So let me put this in the box. All right. Now you should sub this into the integrand and do the usual stuff. You will get alpha. All right. The lower limit minus infinity will go to plus infinity. The upper limit will go to 0. Then you get minus Okay, this is what you get. All right. Now a few things will cancel. Actually, quite a few things will cancel, and I'm going to change one of the minus signs here to change the limits from infinity to 0 to 0 to infinity. So if you do that, and the alpha will also cancel. The alpha here will cancel with the alpha. So if you do that, you will get the following. You will get the integral from 0 to infinity of this is what you get. And this is minus of okay. All right, so that completes question 2. Are you okay with question 2 now? I just finished doing question 2. Right. Okay. One of you guys asked me to do now question 12. So I will go straight to question 12 now, if you do not mind. So can I go straight to question 12, guys, if you do not mind? Okay. So question 12 is, let me find out where it is. It's question 11. Just give me a sec, guys. Okay, yeah. Okay, here we go. All right, now let me go straight to, so are you okay with this, guys? Okay, I hope you're okay. If you're not, just let me know later on, okay? So the next question I'm gonna do is question. I'm gonna do question 12. Now, this is a type of question you will get in every exam and every test. It's basically, I mean, asking you to show that F and G belong to the same domain of attraction, right? So there are three things you need to do. In order to show this, you need to show that A, assume F, sorry, not F, I mean G. Assume G belongs to Gumpel limit, right? Right, and show that F also belongs to the Gumpel limit. That's one thing you need to show. And second thing you need to show is the following, that assume G belongs to the Fresher limit. Okay, and show that F also belongs to the Fresher limit, right? Okay, and C, assume G belongs to the Weibull limit, to the Weibull right, and show that F also belongs to the Weibull limit. All right, so you need to show each of these three things in order to answer question 11 and question 12. So I'm just doing question 12 right now, okay? You should just one. And so let me do part A first, and then if I have time, I will do part B and part C too, okay? Okay, all right, guys. So part A. So let me put this below. So I'm gonna show you how to do part A of question 12, right? So part A, I'm gonna assume G belongs to the Gumpel limit. Okay. All right, that means there exists a function gamma of t, which is a positive function, right? such that such that the limit, remember the condition one, this is the condition one I taught you this week or last, I think yeah, it was on Tuesday this week. So all right. All right, so I'm assuming that this condition holds, right? And let me, for later use, let me call this condition star, right? Now, what we need to show, guys, is that we need to show that the same thing is true if G is replaced by F. So we have to show that, right? That issue replace G by F in this equation. I mean, in the equation star, you will get the same limit, or at least the same type of limit. Okay, so that's what I'm going to show you. I'm going to show you that the limit of this is the same as the limit of this, at least of the same type, right? So if we can show that, then I would have shown that F also belongs to the counter limit, right? Now, the first thing to do this, the first thing I'm going to do is to use the L'Hopital's rule, right? I'm sure all of you know that. So if you use the L'Hopital's rule, yeah, this is what you get, okay? The minus and the minus cancel, so this becomes the limit. Okay. All right. In the next step, I'm gonna use the formula for lit. You should read the question, guys. The question gives you a formula for little f in terms of G, right? So what I'm gonna do in the next step is to replace this expression and this expression by what is given in the question, guys. So let me do that. I need a big, just excuse me. I need a big fraction here. So I'm gonna first replace this here. Sorry, guys. So I need to replace this one first, okay? So you see what I'm doing? I'm replacing f, the little f, by the expression that we are given in the question, guys. All right. So you see what I've done? I have replaced this guy here by this guy, right? And similarly, I'm going to do the same thing for this. All right. I know it looks pretty clumsy, but it will all produce quite a bit now after a couple of steps. So don't worry. All right. Okay. So this is what you have. It looks a bit messy. Okay. You see that this guy here will cancel out with this one. This cancels out with this one. All right. All right. So after in the next step, in the next step, I'm gonna replace WF by WFG, right? Which we are allowed to do that because the question says you can replace WF. They are the same, right? All right, now I'm going to combine the likes with the likes. So for example, you can combine this with this. So that means G all right? That's what I mean by like with like, because these two are the same kind, this one and this one. And this one and this one of the same kind. All right, so you can combine the two. Okay, and then you can combine this one here with this one, right? So you will get the following. You get, excuse me, I'm not. Okay, we get this, right? And then I'm going to combine this with this one. So that's going to give you the following. Sorry, some of you guys are really coming late. I don't know why, but Okay, and finally the term 1 plus x gamma prime t. All right. I know it's still a horrible looking expression. All right now, but this is where a lot of things will simplify. This is where I'm going to show you what happens, because as t approaches the upper end point of G, right? This guy here, by definition, right? This must approach 1, right? That's by definition. Remember, the upper end point of G is the point where the CDF becomes 1, right? And so this will also approach 1, right? Okay, and this will also approach 1. Okay, and this will also approach 1. So you see, you have 1 divided by 1, which is 1, and over here you have 1 minus beta, which is beta in the top, and in the bottom you have 1 minus beta, which is again beta. So beta divided by beta is 1. All right, so effectively these two terms disappear. This term and this term disappear. Right. So in the next line, you will see. Okay, let me go to the next line. Here we are. I hope. Okay, in the next line, limit as t goes to w of g. The only term that's going to remain are this term, and this term, right? So I'm going to, for a certain reason, you will see in a minute, right? You have this term, right? Plus times this term here, which is okay. All right, guys. Are you okay with me, guys? So basically, what I have shown you is that this nasty looking expression is reduces to just these 3 terms, right? All right, now we are not far from the end yet. Okay, we are not far from the end. So this will be, okay, this step is a crucial step. I'm gonna, all right, you see what I've done here is the step from this to this is uses the L'Hopital's rule in reverse. I don't know, I hope you can read my writing. I hope it's the L'Hopital's rule in in reverse, right? What I mean by that is that you should apply the L'Hopital's rule to the top and the bottom. That is, if you differentiate this with respect to t and this with respect to t, you will get precisely what you have here. Okay, the derivative of this with respect to t is this times this, and the derivative of this with respect to t is this. So I have applied the L'Hopital's rule in reverse direction. Okay, all right. So this, okay. I hope you follow me. Let me complete this before I know I've got some couple of questions in the chat box. I will answer them in a sec after I complete this. Okay. So you follow this, right? This step. How I got from this to this by using the L'Hopital's rule in the reverse direction. All right, so these two are the same. So what we have is okay, this is to the power b, right? As t approaches w of g, right? And now we know from star, remember star is the one that I started off with, right? That the limit of this is ef minus x to the power b, right? Which is ef minus bx, which is of the same type as e minus x, right? So hence we have shown, that f also belongs to the Gumbel limit. All right. I know it looks like a lot of work, but once you do a few questions like this, you will be fine. I've got a question from Victor. Why do we get GT equal to 1? All right, let me answer that question here. Why we get GT equal to 1? Yeah, the reason that GT goes to 1 is because as t approaches the upper end point of G, right? The upper end point of G is the value where the CDF ends, right? So in other words, it's the value where G at W of G must be 1. Do I make sense? Because it's basically like you should take the normal distribution. The normal distribution ends at plus infinity. So if you work out the CDF of the normal distribution at plus infinity, it must be 1. Yeah. So it's the same argument here, because if you have a CDF G, right, and the upper end point of that CDF is W of G, then the value of the CDF at that point must be 1. So it's a bit like this. So I mean, like for example, the uniform distribution. For the uniform distribution 0 to 1, the upper end point is 1. So the CDF at 1 must be 1. All right. So that is why I said over here that this goes to 1, and for the same reason this also goes to 1. This also goes to 1. This also goes to 1. So all this disappear and all this also disappears. So the only term that you're left with is this one, and this one. All right, that's what I have here. All right, so you only have these three terms left. All right, and then I applied this is the crucial step. Then I applied the L'Hopital's rule in reverse direction. So when I say reverse, you apply it in this direction, not the other way around, right? Okay. So you get this, and these two are the same. You can combine them into this. Here I use star. Star, remember, is the assumption that we made earlier. Remember, star is this one here. This is your star, all right? So using star, this guy is equal to your minus x to the power b, which is this, which is of the same type as b minus x. All right. So hence, we have shown that f also belongs to the Gumpel limit. So this is only one part. I mean, you need to, the same way you need to show that you need to show B. This is only part A, right? And you need to also show C, right? Then after you show all A, B, and C, then you can say that, then you can conclude that F and G belong to the same max domain of attraction, right? Okay. So this is how you will do question 12, and question 11 is similar to question 12. So if you can do question 12, you should be able to do question 11. All right. And all right. Any other questions you'd like me to do, guys? Guys, hello. Talk to me, guys, please. Or do you have any questions on the quiz 1? Remember, for quiz 1, on Tuesday I did 3 examples on how to do quiz, how to help you with quiz 1. So I got a question from Mike. What do you mean by the final step? I don't understand. Is that Shenzhen? What, I don't understand question. What do you mean by why is it equal to exponential? Oh, okay. That's because of star, Mike. We assumed over here, Mike, that the limit of this is e of minus x.
Right? Oh, I didn't saw that. I didn't see that.
Okay.
Yeah, thanks.
All right, it's good to. So that's why I said that this is equal to this because of star. Yeah. All right, I got a question from Victor. It's about question 6. Question 6 is, let me see what it is. Question 6. Oh, here we are. Okay, question 6 is this one. All right, let me do question 6. So this is question 6, guys. Is to show that all right, is to show that this is true if and only if beta n equal to 0 and alpha n is there. All right, we know that this guy here is All right, okay. This is the CDF of the Weibull distribution, right? So I just substituted the formula for the CDF of the Weibull on the left and the right. Okay. So this becomes okay like this. Now I'm going to take the logs both sides. You should take the log on the left and the log on the right. You get minus of n times this, yeah. And on the right hand side, you will get minus of okay. All right, now the two minuses cancel out, so you get all right. Okay, now the next thing I'm going to do is I'm going to take the power power 1 over alpha on the left and power and power 1 over alpha on the right. Okay, you see what I'm doing? So this becomes okay times minus x. Okay, this is what you get on the left, and on the right you get this. Yeah. All right. Now I'm going to take multiply both sides by -1. You get n. Okay. Now this can be only true if the coefficients of x on both sides are equal and the constants are equal on both sides. The coefficient of x on the left hand side is this, right? And the coefficient of x on the right hand side is this, right? And the constant on the left hand side is 0, and the constant on the right hand side is this. What? So hence we have shown that beta n is 0, sorry, and alpha n is all right. So this completes question 6 of all right. So and question 5 and question 4 are similar. So it just basically, you just start with the with a statement and try to reduce it to the answer that you need, right? So it just simple algebraic manipulation. There's nothing really too difficult about this. Okay, guys. Any other questions or anything that is not clear? It's my pleasure. Yeah. So any help you need, just contact me 24/7 by email or by Skype or Zoom or phone number. I gave you my phone numbers too, so you can call me. Okay. All right. And so just and also just to remind you that the next quiz one is due at 12 noon on Tuesday. Please email your answer to me. So you can write your answer on a piece of paper and scan it and email it. If you're using LaTeX or if you know LaTeX, you can type it in LaTeX. I mean, LaTeX is a good package to learn if you haven't learned it. So if you're using LaTeX, then you can type it in and send it to me as a PDF file. Okay. Yeah. All right, guys. So anyway, so right now I will update the YouTube channel and also the course web page to give the full solution for all the 14 questions. And also I will post 4 different solutions. As you know, the first is the type solution. Second one is the handwritten solution. The third one is the video solutions. And the fourth one is the tutorial solutions. All right, I hope you find all this useful. All right, guys. So have a good evening or have a good afternoon wherever you are. Just please keep in touch. Okay. I will talk to you again soon. I mean, wherever you are. Okay.